The concepts of kilowatts kW and kilowatt hours kilowatt hour are fundamental to understanding how electrical power and energy are measured, utilized, and billed in both household and industrial settings. kW represents the instantaneous rate of power consumption or production, reflecting how much electricity a device or system uses at any given moment. It's crucial for sizing equipment, managing peak demand, and ensuring that systems operate efficiently. Kilowatt hour, on the other hand, measures the total energy consumed over time. It represents the amount of power used over a period, which is how energy costs are calculated. In industries, kilowatt hour determines overall energy expenditure, while kW helps manage load and avoid peak demand charges. In renewable energy systems like solar and wind, kilowatt hour tells us how much energy is generated and stored, while kW defines the system's capacity. These two units are essential for everything from household appliance efficiency and electric vehicle performance to grid-scale energy management in modern smart grids. Kilowatt kW unit of power. At a more advanced level, kW is a unit used not just for household appliances but also for industrial machines, power generation plants, and even electric vehicles EVs. Power plants, for example, are often rated in megawatts MW, where 1 megawatt equals 1,000 kilowatts. For industries, accurate power ratings are critical for optimizing energy use and ensuring that equipment operates within safe limits. Devices like electric motors, pumps, and industrial furnaces all have power ratings in kW that define their energy consumption per unit time. Peak power and demand management. In industrial settings, the maximum kW demand during any given period is used to assess the peak demand charges, which can affect the overall cost of electricity. Large consumers of electricity may also be subject to penalties if their peak kW usage exceeds certain thresholds set by the utility. Electric vehicles EV motors are rated in kW. For example, an EV might have a motor rated at 100 kilowatts, which means it can draw or generate up to 100 kilowatts of power while driving. The higher the kW rating, the more powerful the motor, and generally, the quicker the vehicle can accelerate. Kilowatt hour, unit of energy, kilowatt hour represents energy, which accumulates over time. In industrial or commercial settings, energy efficiency is key to managing operational costs. The goal is often to minimize kilowatt hour consumption while maintaining productivity. Energy audits. Businesses often conduct energy audits to evaluate their total kilowatt hour usage and identify areas for improvement. The audit typically examines each device's kW rating and how long it operates to calculate its total kilowatt-hour contribution to the facility's energy bill. Energy efficiency. Devices such as air conditioning units or refrigerators are rated based on their energy efficiency, typically expressed in kilowatt-hour per year. For instance, an energy-efficient refrigerator may consume only 200 kilowatt-hours annually, while older models could use 400 kilowatt-hours or more. Lower kilowatt-hour consumption translates directly into lower electricity bills and reduced environmental impact. Battery storage. Energy storage systems, especially batteries, are rated in kilowatt-hour. This rating tells you how much energy the battery can store and supply over time. For instance, a battery rated at 10 kilowatt-hours could theoretically supply 1 kilowatt of power for 10 hours, or 2 kilowatts for 5 hours. Larger systems for grid-scale storage may have capacities in MWh megawatt-hours or GWh gigawatt-hours. Advanced applications of kW and kilowatt-hour in various sectors, power generation and utilities, like power plants, whether they are coal, nuclear, hydro, or renewable solar wind, are typically rated in MW megawatts, where 1 megawatt equals 1,000 kilowatts. This rating represents the maximum power the plant can produce at any given moment. Energy output kilowatt-hour. The energy generated by a power plant over time is measured in kilowatt-hour or MWh for larger scales. For example, a 100 megawatts power plant running at full capacity for 24 hours will produce 100 megawatts into 24 hours equal 2,400 megawatt-hours. Renewable energy, like solar panels, are rated in kW, typically referred to as their capacity, and their total energy output over time is measured in kilowatt-hour. For example, a 5 kilowatt solar panel system might produce 25 kilowatt hours of energy on a sunny day, depending on factors like sunlight hours and efficiency. Wind turbines also have a power rating in kW or MW, which refers to the maximum amount of power they can generate at any given moment. The actual kilowatt hour generated will vary depending on wind conditions. A 2 megawatts wind turbine could generate 48,000 kilowatt hours of energy over 24 hours if it operated at full capacity, which rarely happens due to varying wind speeds. Measurement in meters. Power meters for kW measurement. In industries or households, power meters measure the kW being used in real time. These devices give an instant snapshot of how much power appliances or machinery are drawing at that moment. Real-time kW measurements are important for identifying high power demand, monitoring system load for peak demand management, ensuring that electrical circuits are not overloaded. Energy meters for kilowatt-hour measurement. Energy meters, also known as electricity meters, measure kilowatt-hour and are the basis for electricity billing. These meters accumulate the total amount of energy used over time, typically displaying the value in kilowatt-hour. Advanced smart meters can provide more granular data on energy usage, allowing consumers to see energy consumption patterns and adjust behavior to save energy. Smart meters. Modern smart meters record both kW demand, instantaneous power, and kilowatt-hour consumption, total energy used. These devices can communicate usage data to utility companies in real time, improving accuracy in billing and enabling dynamic pricing models, where electricity costs vary depending on the time of day. Power factor and its impact. In industrial settings, the power factor plays a crucial role in how kW and kilowatt-hour are managed. The power factor is a measure of how effectively electrical power is being used. A lower power factor means more energy is wasted in the form of reactive power measured in kWh. Real power kW, the portion of power that performs useful work. Reactive power kWh, the portion of power that does no useful work but is necessary to maintain voltage levels in the system. Apparent power kVA, the combination of real and reactive power. A poor power factor can lead to inefficiencies, and industries with low power factors may face higher costs. Power factor correction devices like capacitors are used to improve power factor and reduce wasted energy. Demand charges and time of use pricing. In both commercial and residential settings, utility companies may implement demand charges based on the maximum kW usage during peak periods. These charges are often calculated based on the highest 15-minute interval of power usage during a billing cycle. The goal is to incentivize users to lower their peak kW demand to avoid high costs. Time of use pricing. In some regions, utilities implement time of use pricing, where the cost of electricity per kilowatt-hour varies depending on the time of day. During peak demand hours, e.g., in the evening when everyone is using electricity, rates may be higher, while off-peak hours, e.g., late at night, have lower rates. This encourages users to shift their energy consumption to off-peak times, thus reducing overall demand on the grid. Energy management and smart grids. With the rise of smart grids, energy management has become more sophisticated. Utilities now rely on real-time kW data to balance supply and demand across the grid, integrating energy from both traditional power plants and renewable sources like wind and solar. Load shedding. In situations where demand exceeds supply, utilities may implement load shedding, temporarily cutting off power to certain areas or users to prevent the grid from overloading. This decision is based on real-time kW demand across the system. Energy storage. Batteries are increasingly used to store energy during times of low demand and release it during peak times. These systems are critical for balancing intermittent renewable energy sources like wind and solar, which don't generate power consistently. Batteries are rated in kilowatt-hour, indicating the total amount of energy they can store. The concepts of kW and kilowatt-hour form the foundation of how power systems operate, how energy is built, and how modern energy management systems are designed to balance efficiency, cost, and environmental sustainability. Understanding these distinctions helps optimize both small-scale household energy use and large-scale industrial operations. Bottom of form.